Hello again, .NET developers. In this video, I'll show you how to create unit tests. We'll use Visual Studio Community 2015 and the MSTest library, which comes automatically with Visual Studio. There are some other unit test libraries you can download and use, like XUnit and NUnit. These other libraries give you some more features, and you're probably going to want to use them for your real programming, but they all work about the same, so we'll just do the demonstration with the built-in MSTest. You may be asking, what is a unit test? When you create a program, you have functions in your classes that contain all the logic for your program. Unit tests call these functions and make sure they return the results you expect. For example, let's say you have a calculator class with an add2numbers function. If you call that passing in 1 and 2, you expect it to return 3. So you could create a unit test that does that. It calls your calculator function and checks to make sure it gets the right result. Unit tests are extremely useful in large programs or if you're working with other developers, because it's very easy to make a change in one part of the program that breaks something in a completely different area that you didn't realize was connected. And the unit test will let you know about that right away. In this video, we'll write some tests for a player class for a pretend role-playing game. The player has a current hit points property, and we have a receive damage method. So when the player is fighting, if a monster hits him for some damage, we subtract that from the player's current hit points. Here's our sample solution with a class library called Engine, and this is where we're going to put in our player class. Normally, your unit tests are going to be run against your class libraries instead of the user interface or the database or the file system, anything like that. You just want something that does not depend on anything else, doesn't depend on the user clicking a button, doesn't depend on the value in a database or anything. You just want to make sure that the function works the way it's supposed to. So here we have our player class. In our constructor, we pass in the number of hit points for the player, and we save that to the current hit points property. And here's our receive damage function, where you pass in the amount of damage, and we subtract that from the current hit points. There are a couple extra rules we want to apply to the receive damage function. If we pass in a negative number for the amount of damage, we want to ignore that. And if we pass in more hit points of damage than the player has left, so if the player has 10 hit points and receives 15 hit points of damage, we don't want them to have a negative 5 hit points, we want it to be 0. Now we're going to create the test project that will hold all of our unit tests. Right click on the solution, select Add, New Project, and in the project type, select Test and Unit Test Project. I'm going to name this Test Engine because I like my unit test project name to match up with the class library that it's testing. And it creates a test engine project with a sample unit test class. The first thing you need to do is right click on the references in your test project and add a reference to the class library that you're going to test. Otherwise, it can't see the player object. And I'm going to rename this Unit Test 1 class to Test Player, since we're going to put our unit test for the player class in here. Okay, now we're in our test player class. The first thing we need to do is add in a using engine. So we have a reference to the namespace with the player class in it. When we look at the test player class, we see it has test class attribute in front of it. This is how your testing tools know which classes have unit tests in them. And our method here, we have test method, in front of it. Again, so that the test tools know here's a unit test. For this first test, I'm going to rename it Test Hit Points Are Subtracted. And I'm going to say player equals new player with 10 hit points. So this will create a player object for us. Then I'm going to say player dot receive damage 3. So at this point the player should have 7 current hit points remaining. This is where we create our assertion. This is the actual testing part of the unit test. So you type a assert dot, and you have a whole list of things you can do here. Are equal, are not equal, are the same, is false, is true. In our case, we're going to test are equal 7, the expected value, comma, player dot current hit points. So what this function will do, what this unit test will do, is create a player with 10 hit points, give them 3 points of damage, and then check to see that the player's current hit points are equal to 7. If that's true, then the unit test will pass. If it's false, then the unit test will fail. Now, in order to run a unit test, you go up to the Test menu option in Visual Studio, select Run, and we will say Run All Tests. And now the Test Explorer pops out. I'll pin this, and we see that our test here, test hit points are subtracted, is green, so it's good. Just to show you what would happen if there was an error, we'll say we expect 6 back. So if I go test, run, all test, and we see there's a red X, and if we look down here at the bottom of the Test Explorer, we see expected a 6, but it actually got a 7. So let's put that back to 7. Run our test just to make sure it works, and we're back to green. So now we'll add some more tests for our other situations. And it's just like creating a function in any other class, except you have to remember to put the square bracket test method in front of it and make it a public void function. And we'll say test negative damage does not change current hit points. Because if we pass in a negative amount of damage, we don't want that to affect the player's current hit points. We'll create a new player object again with 10 hit points. And we'll say player.receive damage, and we'll say -3 this time. And assert are equal 10, player.current hit points. So for this test, we're creating a new player with 10 hit points. We say he receives -3 damage. So we're expecting the player's current hit points to still be 10. Go back up to test on the menu, run all tests. And now we see our first one succeeded, but this one failed. It expected a 10 and it received a 13. That's because we haven't made anything in the player class handle negative numbers. So we'll go back to our player class. We'll say if hit points of damage less than 0, return. So it just skips out of there and doesn't apply the damage. Save that. Go back to test, run all tests. And now both of them are green. This is doing something called test-driven development. This is where you put in your new requirement as a unit test first, and then you go back and you change your code so that your tests all pass. Some people like this. Some people think you end up writing too much testing code and not enough real code. In my opinion, you really need to find a balance for how complex your program is, how many people are working on it. But it is nice to have these around, because if you make a change a year from now, you can run all your tests and be pretty sure that your change didn't break anything new. So let's add another test. This one will be public void test more damage than current hit points equals 0. And we'll create a player with 10 hit points again. We'll say player.receive damage 13, and we will assert r equal 0 and player's current hit points. So for this test, we create a player of 10 hit points. We do 13 points of damage to him. We want him to have 0 hit points. We run our test. And see that this one failed. It expected 0, but we actually got 3. Again, this is because we don't have the code in the player receive damage function to deal with this. So we go back to player receive damage, and let's put another quick and easy solution. If current hit points less than 0, current hit points equals 0. Go back to our test and run them all. And now they all pass. So that's the basics of creating unit tests in Visual Studio with the MSTest library. These were pretty simple tests, but they should give you an idea of the concept. In the next video, I'm going to show you how you can connect up something called continuous integration. So whenever you save changes to your source control, it will automatically run all of your unit tests and let you know if anything failed. This is really nice with big systems, and especially when you're working with a dozen other programmers. You know right away that something broke, so you can fix it. If you have any questions about this video or ideas or suggestions for future ones, please let me know in the comments below. Thanks.